Welcome. In this video I'm going to be talking about information handling software with a particular focus on operators and data types. So in one of the previous videos I talked about the idea of searching a database. So searching. And I gave an example of the fact that we can search on a single criteria. So for example, I might want to search a school database for all of the male students. So I would do a search for gender equals male. And this is searching with a single piece of criteria, and I'm using the equals operator. In another example that I gave, I said I might want to search for all the genders that are equal to male, but I also might want to say, well, I want all of the males that are born before a certain date. So it would be, for example, gender equals male, and so again this is an operator, which we'll talk about in just a minute, and date of birth is less than 19th the 1st. So again, this is another operator that I mentioned just a minute ago, which was it's less than. So this would find all the students that are male and born before 19th of the 1st, 2000. So the operators here is we've got equals, and we've got and. The and is where the data is only listed where both conditions are true. So this condition and this condition need to be true in order for the results to appear. Something that I could have actually done in this scenario, so if I just write this out again, searching, and what I said initially was that I wanted to find all the males. Now another way to find all of the males is to search for everything other than females, because if I had, for example, gender, and I know that in the gender field of a database there would only ever be two values, and that would be male or female. Now previously what I did is I said gender equals male, and that worked fine. Alternatively, what I could have actually done is I could have said gender not equal female, and it would have given me exactly the same results as this. However, the operator that I used this time, if I just rub this out, as you can see, was not the equals operator. I've actually used the not equal to operator. So the less than and more symbol together is the not equal to operator. Also, in the last slide here, I use this less than symbol here. There is an obvious opposite of that, which would be the more than symbol. So for example, if I wanted to find all students whose date of birth is greater than 19th of the 1st, 2000, then I would use the greater than operator to do that. So we've talked about equals operator, less than operator, the and operator. We've talked about the not equal to operator and the greater than operator. Well, what about the or operator? So what I might want to do here is I might want to say, well, I want to search for all those students whose surname equals Smith, or surname equals Jones. What the OR operator will do is it will find data where that is listed where either or both conditions are true. So for example, you are Smith or Jones would in comparison to using the AND operator, this would actually bring back more results, because if I replaced this with an AND operator, it's very unlikely that there are students with the surname of Smith and the surname of Jones. But if it makes sense to say, I want to see all the ones that are surname Smith or Jones, so I'd actually get more results with this. Another interesting operator is the like operator. The like operator. Now what that would do is, let's say for example, again I was searching for surname, and if I was to use something like equals John, then it would find me all those students that have the surname of J-O-N, John. Whereas if I use the like operator instead of the equals operator, so it would look something like this. Surname like John. What that would actually do is it would actually find me all the students that have actually got the J-O-N in the start of the surname. So it would actually find, for example, it would find you if you've got your surname as John, but it would also find you if you've got your surname as Jones, or if you've got a surname of Jonathan. It would actually find all of these results as well. So the like operator is where perfect match is not actually needed. Perfect and close matches are actually listed as well. The last two operators that I want to talk about is similar to the less than and similar to the more than, is greater than or equal to, less than or equal to, or greater than or equal to. So again, working very simple and similar ways to the less than and more than, but this time if I was to say that I wanted to find all those whose date of birth is less than or equal to, so for example, date of birth less than 19th of the 1st, 00, would not actually include this date in the results. So if there was a student whose birthday was, or date of birth, was on the 19th of January 2000, it wouldn't actually show them. As opposed to the fact that if I used the less than or equal to, 19th of the 1st, 00, well then this result here would actually appear in the results, because it does equal to that. And again, the more than symbol would work similarly. So date of birth greater than or equal to 190100 would actually bring this result up, but if I use the more than symbol, it would not. It would only find ones that are more than 19th of January 2000. So there we've just covered operators, but I also want to talk in this video about data types. Now, in information handling software applications like databases, we have to decide very early on what data we need to collect and what data types that data will fall in. So here are the data types that you could choose in a database. So if, for example, you had a table in your database like this, and for example here I had an ID field, here I had a surname field, here I had an age field, here I had a yes or no field, so takes the bus. This person take the bus or not, it's a yes or no. If I just look at these ones, for example, and I fill it in, for example, the ID here would be ID 1, surname Wood, age 16, takes the bus, yes. And I might have another record where the ID is 2, surname Smith, age 16, doesn't take the bus, cross. And then again I might have another one whose name is Sam Wood, she is 16, She takes the bus. Right, what we need to look at here is the data types that we're actually storing inside this database. So, for example, this ID field here is not storing textual data, it's actually storing a number. And we could set this data type as number if we wanted to. I'm just going to write that in there. We could set the data type, in fact, if I just write it in red, we could set the data type of this field to number. However, what that would mean if I was using information handling software is that I, the user, would actually have to type in these individual numbers here. Now that's fine, but if I've got, say for example, 2,000 students on roll, and I have to type in a unique number there every time, because obviously the ID would be a unique number, to identify, for example, there's 2 people with the surname Wood here, they were both 16, so I need a way to distinguish which one's which, and that would be their unique ID number. Now, if I had to type those in myself, it's likely that I might actually make a mistake when typing in this ID. So instead of actually setting this data type of this field to number, there's another data type called auto number. This data type is where the database application, the information handling software itself, will automatically make sure that a number appears in this field that is unique. So for example, I don't accidentally, if I just set it to number, I might accidentally type in the next one with the ID number 3 and nothing would stop me. Whereby, by letting the computer assign an auto number, it will automatically choose a number in here that has not been used before. So one of the data types within information handling software is auto number. This field here would actually have a data type of text. Now the text data type can be a little bit deceiving because text actually allows for any sort of character to appear. It tends to be used for things like names, any fields with words, but it also accepts numbers that are not used in calculations. So for example, if I was to set, this was phone number, if I was to set phone number with the data type of number and not text, well then if someone's phone number might be 0565213. Now you try and type that number into a calculator and it won't appear because you can't have a number that starts with 0. You can if it's a decimal number, but you can't have a whole number, an integer. You can't have a whole number there because, again, you wouldn't be able to type that into a calculator. So, for example, a phone number field would actually have to be set to the data type text because a text data type allows numbers and letters. Let's just rub this out. So these 2 fields here would be set to text. This field here would be set to number because it contains an integer, a whole number. The take a bus field would actually be set to a data type of Boolean. And Boolean is it's a true or false, a yes or no, a 1 or 2, a 0 or 1 data type. So 1 or the other option. So for example, if I was to put this takes a bus as a Boolean inside my database, in my information handling software, what would actually appear are probably some tick boxes because it can either be a tick or blank or a tick. So at the minute I've discussed in this video 4 different data types. Auto number, where it creates a unique number for you automatically. Number is a data type which allows us to put a whole integer, a number in that field. Boolean, which is a yes or no, 0 or 1, a true or false, and text, which allows numbers and characters. Other data types would include date, that obviously would have a format to it. So, for example, it'd be the 2 days, the 2 numbers for the month, and possibly a 2 or a 4-digit number for the year, so 1981. We've also got time, which is a data type as well, and again that time could be in a format of hours, minutes, and seconds. We also have a data type of currency, which again would be a monetary value where it would automatically put in, for example, the required symbol. So you put in the pound sign, or it might put in the dollar for you. And then we might also have data types that are slightly different. For example, you might have a picture data type, and inside there it would contain a picture. You might have a sound data type. Inside there it might contain a sound, obviously, or you might have a video data type. And then last but not least, we have another data type that you need to be aware of that is called a list. A list is useful because if you imagine a table, if you know that you have, for example, a limited number of choices that people should be able to choose from in this field, you could actually create them a list. So for example, it might be you want to choose their tutor group, and you know that there is only 9WD, 9KG, 9CW, or 9KW. And so the advantage of this is that the user is actually presented with a list for them to choose from, and they can easily select the option that they want. So in this video I've talked about a variety of different data types that we have access to in information handling software. I've also talked about the different operators that we can use when searching using information handling software. And so we have actually covered information handling software, operators, and data types.